Hi. Today we are going to talk about why does your data center need hyper-converged infrastructure? A little bit about me. I'm Chittra, working for VMware Software India Private Limited. So my work involves working on a lot of products which is related to hyper-converged infrastructure. I work on their virtual SAN solution, virtual volume solution, their backup and recovery, as well as Windows clustering services and all. So, as I am very much in this domain, I would like to talk a little bit about what is hyperconverged infrastructure and how you in your data center can use this infrastructure and take advantage of it. So, running through a quick agenda, we'll discuss about the traditional data center. This is just to give an idea of what is there in your data center so that you get to know what all components that you're going to relate to. And then we'll talk a little bit of software-defined data center, as in what the companies are moving towards now, because software-defined data center is a big thing, and if you're not catching up with it, you're missing a lot of things. Then we'll discuss about converged infrastructure, which also a lot of companies have started adopting to. And then we'll talk about hyper-converged infrastructure. Obviously, it's like a betterment of the converged infrastructure. And we'll talk about what are the advantages of if you go for hyper-converged, why you should go for it, and how you will be able to, what kind of data centers can actually make use of this hyper-converged infrastructure. And in the last, I'll just touch upon a little bit of the solutions available in the market, and then we'll just open it for Q&A. So getting into the traditional data center, this is how the traditional data center was looking, is what I would say, because there's hardly very few people are still following this approach. But just to understand what are the components of a data center, you can make use of this. So what we used to do is for each department in an organization, you would ideally segregate them into islands and then give them the physical server in which you will deploy applications for them to work on. So, for example, if you take your own laptop, that itself is a physical server in which you are deploying multiple applications. Like you are done installing your Windows OS and you are putting applications on it to work on. And as well, let's say a banking or you are a HR department or any department, you'd be generating huge amount of data. So all this data also has to go and sit somewhere, right? So you will be having your backend storage array, or where all the information will be sitting. And obviously, you need some kind of connectivity between your physical server and the storage array, between the physical server and another physical server as well. So networking also will play a role into a data center. And so the main components when you look at a data center, it would be your physical server, it would be your networking, as well as your storage in the backend where it will be storing all your data. And also another thing that you have to do is some management software. You obviously need some kind of software to manage your servers or some kind of software to manage a storage array. You should know how much of storage is being used, who is using which storage and all that. So obviously those kind of UI also will be needed. The main disadvantage of this approach is the resources are getting waste and it's a very costly approach. For example, when you take one physical server and you give it to just one person or one department to use, there are a lot of resources in that physical server that is getting used, underutilized, that would be the right term. And in the same way, a storage array, you are dedicating a storage array to one department or to a one person. And it's in all probability only half of it will be used, but the other half may not even be provisioned. So this is a very costly approach, and that is where the software-defined data center comes into play. We'll quickly go into what is software-defined data center approach. So here we saw the four components of a data center, right? Like the storage, the compute, the network, and the management. Now, we need a mechanism to actually make all these components virtualized and easily accessible through software. why we need this approach is what you have to think about. Nowadays, we are all moving towards cloud computing and cloud services. So a lot of small scale organization as well as big scale organization, we don't really invest on getting a physical hardware or storage array. Most of us sometimes look into the cloud and say, hey, I need two machines to work on, give me 1 petabyte of data along with it. And the cloud service provider is going to provide you some virtual machines, which to you will look like a physical server in which you are working. So we are moving to an approach which is service on demand provided, right? Even in your data center, in your company or in your lab, you can follow this approach, wherein you have your server, you're virtualizing your servers, and you're deploying multiple virtual machines in one single server, and you are giving it to multiple users. So your physical machines are not limited to just one person. It's being used by multiple persons, as well as even your storage provisions are being used by multiple resources. So when we are moving towards a service on demand approach, we need something that's able to cater this need also. That's when we are having a software defined data center. Now, when you see the compute part, we already have a lot of server virtualization in the role. At least for a decade now, we have VMware server virtualization, Microsoft hypervisors. So all these are already playing a major role. And even the networking part has been virtualized now. We have software-defined networks wherein you don't really have to invest on separate physical switches. You create islands of virtual LANs and stuff so that is also virtualized. And if you come into the storage point, that is another major revolution happening there, software defined storage, wherein you are not going to, you are no longer going to say, I have this LAN, make use of it. It has become like the virtual machine will demand, I need this much of data, some data replication software should be there, some mirroring option should be there, the backup should be enabled. So give me some storage that caters to all these needs. The VM is now going to give policy and tell you, and your storage array will say, I'm able to map these settings, you can use my storage. So this is the kind of approach we are going towards now. And obviously you have all the management software that is automated, so that if a request comes in, it can quickly decide where to get the physical server, where to get the software storage, and how all the servers can be linked through network. So why I'm bringing this topic into here before hyperconverged infrastructure is SDDC is one concept which every other organization is adopting to now, and there are multiple ways in which you can attain this software-defined data center. So, and one of the way to attain software-defined data center is hyperconverged infrastructure. In fact, it is the ultimate epitome of software-defined data center implementation. So, I hope you are clear with what SDDC is. So, let's see how hyperconverged infrastructure or converged infrastructure is used further to implement this. So a couple of years back, we came, not couple of years, it's almost there in the market for like 5-6 years now. We came up with this concept called converged infrastructure. So in converged infrastructure, what we would do is, for example, when you take the traditional data center, right, you'll have racks and racks of server in one place. You'll have network storage array in another place. You'll have the switches in another place. You will have to connect from here to here, here to here. The messy wiring you will do, occupying a lot of space. Now, what we came up with Converged Infrastructure is some of the partner companies came up together and they said, hey, I am very good at providing servers. I'll provide the server. And you are good at networking. You give me the networking component. And you are good at the storage. Give me the storage component. So these partners work together and created a compatible hardware which can be assembled together in a single rack. So in this slide, you are seeing an example of how VCE came up with partnership of Cisco and EMC Square. So in VCE, what was happening is the EMC had servers as well as storage array, and Cisco had the good networking. So you would be assembling all these parts. It is still not a complete solution that is being given to you. It is like a compatible set of hardware given to you, and what you need to do is like building blocks. You would just be building a data center out of it. So in one single rack you are actually getting all the components together, but still it is still not a complete solution. You are the one who's going to be building all the components and ensure that everything is assembled properly and working. There is still a vendor gap also here. So let's say you are facing some issue, um, and you think it could be, let's say your application failed and you think it was running in this server. So let me contact this vendor and file a case against them. Now, when you contact the server vendor says, "Hi, hey, I don't see anything pertaining to me in this log. So let me, probably you should check it with the network vendor or the storage vendor." Now you go to the network vendor and say, "We face this issue. It could be because of a network issue, because of a delay. What is your thoughts?" And they look into the logs and say, "This is probably must be a storage issue." And then you go to a storage vendor and they say, "In all probability, when this storage vendor used with this server vendor, we are facing this issue," right? So the ball gets shifted from one code to another code to another code, and by the time you actually realize what is the issue and who is going to resolve it, a lot of time gets wasted. So this multi-vendor concept is still there in this converged infrastructure. And the another problem is, in this solution, storage is not actually virtualized. You are just taking the storage array that is available and then you are putting it into the rack. The software-defined storage approach is not actually implemented here. There is no policy-based placement of VMs, or you cannot define, "I need this services from the storage, please provide me that." So that has not yet happened. So this infrastructure is more like, "I need these components and these vendors have come up with compatibility guide. Let me just take these components and assemble it together." So that's where a converged infrastructure was lacking. It was still more like a data center in a compact form. And that's when we came up with this solution called hyperconverged infrastructure, wherein the concept might still look the same to you, where you have your storage, your server, and the network all are packed into one rack. But the thing here is, it is one vendor who is going to assemble everything for you, and they will be delivering this as one product. So this is, as well as you're just purchasing a physical server and then you realize everything is set up for you. There are multiple ways in which they are achieving this. One is, for example, one node can have a server, the storage attached with it, and the networking. And there might be another converged infrastructure. You can create clusters of it. The nodes within the servers, right? The servers that has the storage available within the servers are made use and created one shared pool of storage. So different vendors have different approach of implementing this hyper-converged infrastructure. But the concept of your server getting virtualized, your network getting virtualized, as well as your storage, policy-driven approach of storage. So all these three concepts are brought in together into the hyper-converged infrastructure. Now, looking at why you should go for hyperconvergence, mostly let me just tell it as advantages of hyperconvergence. So advantages mostly is software focused. When you mean software focused, You have just one management interface. It's very easy. A lot of vendors, what they have is you just power on the physical servers and then just give the IP that is in your company network, and then the appliance would take care of deploying the complete hyperconverged infrastructure for you. You can also specify, I want to add this appliances into one cluster. So you have one appliance which by itself is going to have multiple nodes and multiple storage attached to it, and then you combine it with another hyper-converged infrastructure, making it into one cluster. So the resources get shared, and it's very easy for you to deploy. There isn't much of cabling or anything for you to do. And even if you're deploying virtual machines in it, it's very simple for you to just uh, automate things using applications available. A lot of vendors, for example, if you take the VMware product, they also come up with a suite of things along with the hyperconvergence, which will facilitate you to just make use of the software already available and deploy the virtual machine or take a backup or anything that you can do with it. So it is much easier to use. And coming to the cost wise, it is actually a lesser cost, mainly because they use the x86 hardware. You are not going across multiple vendors to purchase, get quote across from different vendors and all that. So it's one vendor that you're purchasing with. Even if there is any issue you're facing with that product, it's still one vendor that you are filing the complaint and getting it resolved. So it's a vendor specific product. It can be looked as a pros and a con, but still getting an issue resolved with one vendor and negotiating for a quote with one vendor is much easier. And it's very simple to manage because let's say data centers, right? We don't really concentrate the data centers to one location because we always want to protect our data and all that. So what will we be doing? We'll have a local data center, and in a remote site you will have another data center located, so that the data that is stored in one place is always stored in another place, replicated in another place as well. So even if one of your site goes down, your remote site is made up and available for you to work immediately. So it's you can have a hyper-converged infrastructure, the appliance in one place, another appliance in another site. It's a remote site, uh, separated with distance, and then you can have a cluster of this. And you sitting at one place, you can manage all the appliances across the different sites. So one centralized system of management you have, whereas you are monitoring all the remote sites. So these kind of provisions also you have, which obviously mean you're cutting down your labor. And if anything goes wrong, you have a monitor tab. You can say this happened, this is happening in that side. So what is wrong? We can just rectify it by looking into the monitor. You can look into the performance tab and then say, there is more load on one side, let us just move the data from one side to another. The workload can be migrated easily. So all this is possible. And when it comes to scalability, it's again simple because we are going to create a cluster of hyperconverged infrastructure, right? So when one appliance has been deployed, you are obviously going to deploy another appliance. And now if you want more storage or more compute power, or if you want to expand your data center, it is still simple. What you have to do is add in another appliance into your cluster. So you can keep expanding the cluster as per the vendor specification. So how much of a limit is there, you can keep expanding it. So scalability is very simple. Whereas let's say you want to go for when we compare to legacy system, right? When one storage array gets over and you want to scale to the next storage, it's a big deal because one is you're purchasing a lot of things, and it involves a lot of cost, and then you are going to um, you need the rework of which server should be able to access which storage and all that. So the assignment of storage to the servers, all that will be complex. But let's say you're taking hyperconvergence, you are just adding one node to the existing cluster. You're just adding one node to the existing cluster. What happens is that storage is immediately made available to all the nodes in the cluster. You don't have to be sitting and doing anything for it to make visible. Every node in a cluster is made available of all the resources available in the cluster. So that is why automation is also very easy. And because, for example, if you want to deploy a VM and all that can be easily automated. And to keep track of a storage or keep track of the machines, all this can be easily automated. Because a lot of vendors come up with the softwares also. They provide you with the APIs. Using those APIs, you can create the automation, your own automation script, and schedule backups, and all that can be done. Policy-driven VMs, like how I was talking about the software-defined storage, right? This is very important these days because when you are moving as a cloud service provider or even in your data center lab as a service provider, service on demand. So when you are going like that, the shift is moving towards a VM demanding the kind of storage it wants rather than the storage telling, I have only this, make use of it. So the VM will now tell me, I want a data protection to be enabled. I want RAID 1 or RAID 0 configuration should be there. I want the RAID schedule backup should be there. And your array will be exposing its capabilities. Your storage is going to be exposing its capabilities. So when you are deploying VM, you can mention these capabilities are required for my VM, and the infrastructure will tell what are all storage available suiting your needs. You can then select which storage that VM should go and sit in. So that's policy-driven VMs and shared resources. Like how I said, once you add a configuration in one cluster, everything is going to be shared across all the nodes. That is one thing. Data protection is another. That is a lot of hyperconverged vendors provide that option, right? Even otherwise, you are deploying the infrastructure across multiple sites, and when you are writing in one site, you obviously make a write in another site or take a regular backup. And these kind of things are very important for any data center. Nobody wants to lose any data. So some of these solutions, or I would say, the requirements of all an SDDC is being met by the hyperconverged infrastructure. So now that we saw the advantages of it, who can adopt to a hyperconvergence, or what kind of data centers can go towards it? So, like we saw, it caters to all the needs of your SDDC. So, if you are a data center, if you are a new company or a new cloud service provider, or you are trying to establish a new data center, hyperconvergence is what you should be looking at, because that is where the technology is going towards. That is where your modern data centers are walking towards. And if you are not going to be compliant to it, you are going to fall back. So if it's a new greenfield setup, or if it's a new data center that you are altogether setting up, then it's highly recommended for you to look into all the hyper-convergent solutions available in the market. And why another reason, or when you go for different kind of storage available, because sometimes in traditional storage when you buy, what happens is it can be all SATA disk or all SSD disk or all flash disk. So based on the performance, based on the price that you can afford, you go for buying the different kind of storage. But now in hyper-converged infrastructure, right, So each vendor have their own specification, or even you can demand. You can say, I want the server to have this compute power, and I want my storage to have an all flash array because I want a better performance. Or you can see a mix of SSD and flash should be there. So all these kind of storage is available in a mix. So you're not spending for a lot purchasing an all flash array, or you're not making use of the function available from an all flash array, the performance provided by an all flash array. So you have a mix of storage available provided by this hyperconverged infrastructure. So if your environment is looking for a little bit of high performance, a little bit of SSD as well, because sometimes you just want to store data, right? Like backup or something. So you don't want an all flash in that case. You just want the data to be stored somewhere protected. So for that, you can demand, I don't want flash, just give me SSD. Or it can be a tier 1 application that you are trying to deploy. In that case, you would say, I want an all flash. And your vendor will be able to provide you with an all flash, because a lot of them have different specifications. So a mix of storage is available for you to purchase. It is not that you'll be spending fully on flash or fully on SSD. It's not like that. So that is one. When your environment is looking for the kind of mix of all these kind of storage, you can think about it. And single management system. Obviously, this is obviously when you don't want to spend much on labor, or you don't want a lot of remote sites. And when it is a single management system, the coordination is also very simple, right? You just have to be looking into all the data centers sitting at one place, which is much easier to manage. So when you want for a single management system, when your data center management is at one place, and your hyperconverged infrastructure is just deployed in remote sites where you can monitor it. So those kind of things you can adopt. And efficient backups, like it said. Vendors also provide backup software along with that. That is one thing. And the second, you can also set up the remote site and the local site. Thereby, you are also implementing disaster recovery. Because when one side goes down, your other side is always active and it quickly picks up. So if you're looking for deploying tier 1 applications on a hyperconverged infrastructure, those kind of appliances are also available. If you want to limit it to just a test and dev environment, right? You can just buy one appliance and use it. That's also easy, right? You just have your server, compute, storage, everything available in one box. So going from tier 1 application to taking backup to being a disaster recovery, or just using in test dev environment. So when any of these is your demand in the data center, or if you are moving towards cloud where you want to provision VMs and resources on demand, automation is very simple in this case, and that's when you should be going for hyperconvergence. And like how we discussed in the beginning about software-defined data center, all the requirements of SDDC, or all the things required for an SDDC to function properly is all adapted by hyperconverged infrastructure. So if at all you're going for something new, it has to be HCI. I'll touch upon a little about Evaro. Evaro is a product that's coming from VMware, and it's the hyperconverged solution that is being provided by VMware. So what happens here is we have 4-node systems. It makes use of vSAN, it makes use of VDP for backup, it makes use of VRA, your automation is available, your VDI setup is easy. So when you buy this suite, a lot of other software suites that is provided by VMware also comes along with it. And it makes when you mean it makes a virtual SAN, that's again another product from VMware. But how it functions is I have four hard physical servers, and the physical servers in turn comes with storage, right? Your laptop has some GB of storage. Similarly, and now physical servers are capable of, and the physical servers are now capable of holding petabytes of data. So these physical servers have local storage. We are combining this local storage, pooling it, creating a cluster, and making it into one big storage. That looks like a one big shared storage across all the nodes. So this is also using the policy-driven approach. You have the backup possibility. So this is one of the good solutions that is available from VMware. And obviously, it is partner tested as well. Um, so if you are considering about going for a hyper-converged infrastructure, you have different solutions available from VMware as well. And looking into other solutions available in the market, you have, I mean, I just touched upon Evaro. Nutanix has been there from quite a while. And then we have SimpliVity. That's the OmniCube from SimpliVity is also been available for quite some time. And then we have Gridstore. There's many more solutions available. So the basic thing is each vendor have their own specification. So when you go for a vendor, you need to look for what is the compute power that you're looking for, what is the storage that you're looking for, and the cost factor obviously involves, as well as whether you, as I said, whether all flash or SSD. So depending upon your requirement, you can go for the different hyper-converged solutions that's available. So with that, we come to an end of the hyper-converged infrastructure deployment in your data center. So if there is any questions that you want to shoot, you can always mail me at chitra.edify@gmail.com or mc@vmware.com. I'm available in LinkedIn as well and in the name Chittra M. So if you have any questions, please shoot me to this mail ID. Thank you.
Thank you so much for your presentation. We really appreciate it. I will put a copy of this recording up on our website within an hour, so you can share it with friends and colleagues as well.
Yeah. So do you need the slides?
That would be great. If you could email me the slides, I'll go ahead and